Today we're going to talk about bone formation and remodeling. The goal of this video is to explain the mechanism bones use to maintain homeostasis and describe how a broken bone is repaired. So how is a bone formed? An embryo skeleton is made of cartilage, and near the third month of embryo development, osteoblasts begin to secrete mineral deposits that replace cartilage. The osteoblasts then mature into osteocytes. And this process of incorporating calcium and minerals into cartilage to become bone is known as ossification. Primary ossification occurs during fetal development. Secondary ossification occurs during childhood and adolescence. As a child grows, tall columns of chondrocytes, which are cartilage cells at the epiphyseal plate, divide and then deteriorate as the matrix around them calcifies. These cells are then known as osteoblasts, which form spongy bone. Osteoclasts secrete acid to enlarge the medullary cavity as the bone grows so that marrow is available for all cells. Now, what is the composition of bone? There are organic components and inorganic components. Let's start with the organic components. So 35% of bone is osteoid. Osteoblasts build bone tissue by secreting this substance called osteoid. The osteoid provides the flexibility and tensile strength required to keep bones from constantly breaking. The osteoid is made of collagen, and if you lack collagen, this leads to brittle bone disease. The other 65% of a bone is made of inorganic matter, specifically mineral salts. Crystalline salts are made of hydroxyapatites. Here's the formula. This provides bone strength and hardness. Lack of hydroxyapatite causes rickets, and this is a disease that causes softened or weakened bones in children. Now, how are bones remodeled? Because calcium is so important in your body, a certain level needs to be maintained in your blood at all times. To maintain that level, bone is created or dissolved. Think of your bones as a storage tank for calcium. There are two hormones that trigger these processes: calcitonin and parathyroid hormone. This image summarizes how your bones maintain homeostasis using those two hormones. Look at the center of the image. Your blood has a certain level of calcium in it. Say that the amount of calcium in your blood increases, and now it's too high. That takes you to the left side of the picture. Your thyroid gland will begin producing the hormone called calcitonin, and this causes your bones to absorb calcium that's in your blood. By absorbing calcium from your blood, that lowers the amount of calcium that's actually in your blood until it gets back to its set value. Now, return to the center of the image. Say the amount of calcium in your blood decreases and it gets too low. That takes you to the right side of this picture. Your parathyroid gland produces PTH, parathyroid hormone, which triggers osteoclasts to break down bone in order to release calcium. The release of calcium from your bones then causes the calcium level in your blood to rise until it is restored to its set value. Let's finish up this video by discussing how a broken bone is repaired. If a bone is broken, the cells forming that bone begin to die, and blood enters the wound. At that point, a hematoma forms. Hematoma is a pool of mostly clotted blood that forms under the skin, creating a bad bruise. Phagocytes then ingest the dead bone cells and debris. Next, blood vessels begin to grow. and cartilage forms to hold the bone together. This is called a bone callus. Though it holds the bone together, it isn't yet strong enough for the bone to be used. Next, the callus ossifies. Spongy bone forms to replace the soft cartilage. Finally, compact bone forms. Osteoclasts form a larger medullary cavity. Spongy bone is then converted to compact bone. So to sum up, bone is formed as cartilage calcifies. The osteoid portion of the bone provides flexibility, while mineral salts give bones strength. Hormones direct the constant remodeling of bone, and when a bone is broken, a hematoma forms, followed by a callus, and the callus ossifies, and ultimately this repairs the fracture.